Let's talk about our final type of t-test, an independent samples t-test. In this test, we will again have two sets of data, but this time we will ensure the data is from two unrelated groups. We no longer want to have matched data to run this test. In an independent samples t-test, we will compare the means of two separate groups to determine if the group means are significantly different or not. Returning back to our IMDb data, let's compare the average voter rating for two different types of movies, dramas and comedies, to see if the ratings differ on average. First, I will need to separate out the data from my data set. I will pull out the set of ratings just for the comedy group and separately for the drama group. Once I have separated out this data, I can calculate the average rating for the comedy and drama groups separately. Notice here in my data, the two groups do not have identical sample sizes. That is perfectly fine for this test. To begin our test, we will again check our assumptions. First, we have to ensure we collected a random sample of data, which I did when I created this data set using a random number generator. Next, we need to make sure we have a normal population or large enough samples. In this case, both my samples were large at 76 and 86. Since we now have two samples, we will have to ensure both samples meet this condition separately. For this test, we will also add a third condition. That is, that these are independent samples, so no person could have been represented in both groups. Since I separated my groups by selecting the primary label for each movie, and then I separated the groups that way, I ensured that no movie was listed as both a comedy and a drama. Now we can write our hypotheses for the test. Here you can see that I have made a change in my notation from our previous tests. Because we are now comparing two separate populations represented by two separate samples, we will use two mu's in our hypotheses. But similarly to what we did with the paired test, we will be looking to determine if there is a difference or not between these two groups. Again, our null will be set equal to 0, indicating no difference between the values, and our alternate will be set not equal to 0, indicating there is a difference. Our formula for our standard error for this test is the biggest change. Now that we have two separate samples, we must combine their data to create a single standard error. We will use the separate values for the two means, two standard deviations, and two sample sizes to create our single t-statistic. You can see here how I calculated a t-statistic of negative 2.23. Now, we need to compare this to our critical. For our independent t-test, the calculation for the degrees of freedom is actually a bit more complicated. The formula is displayed here. When you calculate your t-statistic with technology, it will provide you with the degrees of freedom achieved with this formula. However, if you are doing the test on paper, you can use a simpler rule of thumb, which is to take the smaller sample size minus 1 to estimate the degrees of freedom. These two degrees of freedom calculations will most of the time be different, but the value achieved with technology is always the more accurate one. Looking here, that you can see for our t-statistic of negative 2.23, comparing it to our critical value of 1.98 gives us a decision to reject the null hypothesis. Given the results of the test here, you can see our p-value is also less than 0.05 at 0.03. Our confidence interval for this test also does not include 0, both further validating that we have a difference between the movie genre ratings. The best way to compare our groups visually is through a bar chart of means. Here I have created one for our data. The height of the bars represent the mean ratings for each group. The error bars then are the black lines at the top. I calculated these based on the standard error for each group. Using this visual check, we can check for an overlap of the error bars. If the bars overlap, meaning there is a way to draw a horizontal line that crosses through both error bars, then it indicates there is no significant difference between our groups. However, if the error bars do not overlap, there is likely, but not always, a significant difference between the groups in our population. In our chart, the error bars do not overlap. You can see I can draw a line that goes between them, but not through both of them. We have a final set of evidence then that our groups differ significantly, and you can state from our results that on average, drama movies have a higher, significantly higher rating than comedies on IMDb. This was our final type of t-test. We now have learned the 3 variations of this test: one sample, paired, and independent.